Hello, wonderful people! Here we are in chapter 36. This is a chapter on magnetism. We're going to do a couple of chapters on the effects of magnetism. This is just an introduction to the chapter, so it's going to go quick. Oops. Magnets are fascinating. Bring a pair close together and they'll snap together and stick. Turn one of the magnets around and they repel each other. A magnet will stick to a refrigerator door, but it won't stick to an aluminum pan. Magnets come in all shapes and sizes. They are popular as toys, are utilized as compasses, and are essential elements in electric motors and generators. Very true. Magnetism is very common to everything you see, for it is an essential ingredient of light itself. The term magnetism stems from certain rocks called lodestones, found more than 2,000 years ago in the region of Magnesia in Greece. And where is that? So here I am in North Adams, Massachusetts. Scroll out, and there we go. There's all of the United States across the Atlantic Ocean. And now we're looking at the Mediterranean Sea. There's Europe, Asia, Africa, Middle East, and here in the middle of the Mediterranean Sea is Greece. So if we zoom in on Greece, there's Athens. You may have heard of that city. And here is this bay, and this is the region of Magnesia, right here, all around that bay. So Greece is where Western civilization got its start, the Western civ that we know, over 2,500 years ago, and that's where they first found these lodestones, which were named after Magnesia, and guess where the word magnet comes from? You got it. In the 12th century, the Chinese used them for navigating ships. In the 18th century, the French physicist Charles Coulomb, you remember him, that's where we got the word Coulomb for the amount of charge. Coulomb studied the forces between lodestones. We now know that lodestones contain iron ore, which has been named magnetite. Again, magna from the area in Greece. Electricity and magnetism were regarded as unrelated phenomena into the early 1800s. So nobody ever realized that these two things were connected until this changed in 1820 when a Danish science professor, Hans Christian Ørsted, discovered a relationship between the two while demonstrating electric currents in front of a class of students. When electric current was passed in a wire near a magnetic compass, both Ørsted and his students noticed the deflection of the compass needle. This was the connecting link that had eluded investigators for decades. All right, side note. We can only speculate about how often such relationships become evident when they aren't supposed to and are dismissed as something wrong with the apparatus. Ørsted, however, had the willingness to see what was in front of him and not make assumptions. He got to find nature was revealing another of its secrets. Lucky him. Other discoveries soon followed. Magnets were found to exert forces on current-carrying wires, which led to electric meters and motors. The stage was set for a whole new technology which would bring electric power, radio, television, and the internet. The end.